Usually, when we think about a cybersecurity breach, we tend to picture this like high-tech brute force scenario. Someone hacking into a mainframe, lines of green code falling down a screen, digital alarms going off.
Right, yeah, the classic Hollywood hacker imagery.
Exactly. It feels like a really aggressive, noisy break-in, kind of like a bank robber kicking down the front door.
Totally. And I mean, we're comfortable with that concept because it just mirrors physical security, right? Like
Yes.
a reinforced door being battered down by a ram.
Yeah, but looking at the threat intelligence report sitting in front of us today, that aggressive, noisy image just feels completely outdated. So welcome to the deep dive.
Glad to be here.
We are unpacking three critical developments today from a really interesting stack of fresh reports. We've got stuff from Elastic Security Labs, Trend Micro, ESET, and Group IB. And looking at these three threats, so a banking Trojan, a highly stealthy Linux rootkit, and this massive App Store scam there is just this really chilling through line.
There is. And it's that these attackers they're no longer trying to kick down the reinforced door, they're just asking to be let in.
Right.
And they're doing it through the weaponization of trust. So the core strategy across all these campaigns, it relies on hijacking the very foundations of our digital confidence.
Which is terrifying. I mean, we're talking about trusting an email from a good friend or trusting a foundational piece of developer software or, even just trusting the official app store right on your phone. Attackers are turning those implicit assumptions of safety against us.
Absolutely.
So let's start by looking at how this plays out on the individual user level. This is from a report by Elastic Security Labs on a banking Trojan called TCL Banker.
Right. So Elastic tracks the specific cluster of activity as REF 3076, and it's a highly sophisticated evolution of an older malware family that we knew as Maverick or Water Saucy.
Oh, okay.
Yeah, and the ambition here is incredibly broad. TCL Banker is currently programmed to target 59 different financial platforms. So that's traditional banks, fintech apps, cryptocurrency exchanges.
And the infection chain is where this manipulation of trust really begins, right? Because the victim just receives a standard ZIP file.
Yeah, a ZIP file. And inside that ZIP file is a malicious MSI installer. But rather than just running a piece of obviously malicious code, the malware actually abuses a legitimate digitally signed program from Logitech.
Wait, like the mouse and keyboard company?
Exactly. It's an application called the Logi AI Prompt Builder, and it uses a technique called DLL sideloading, specifically targeting a malicious file that it names screen_retriever_plugin.dll.
Wow. Okay, so for those who might not know, DLL sideloading exploits how Windows operating systems actually locate software libraries.
Yep.
When a legitimate program runs like this Logitech app, it has to pull in external functions from dynamic link libraries or DLLs, and the operating system usually looks for those DLLs in the same folder as the application first before checking the system-wide folders.
Right, so the attackers literally just drop their malicious DLL into that application folder, and they give it the exact name of a legitimate Logitech plugin. So sneaky.
I mean, when the authentic Logitech executable launches,
Yeah.
it unwittingly just loads the attacker's code directly into its own trusted process memory.
It's like someone sneaking into a highly secure building by showing up in the exact uniform of the trusted cleaning crew.
That is a perfect analogy, yeah.
Right. The security guards, or in this case, the computer's operating system, they see the legitimate Logitech badge on the main program, and they just wave the whole crew right through the lobby.
Exactly. But once that malicious cleaning crew is inside the building,
Yeah.
they don't just start stealing things immediately.
Right.
They systematically walk around and rip the wires out of every single security camera.
Oh, man. So how does it do that?
Well, the very first action this malicious DLL takes is to activate this comprehensive watchdog subsystem to blind the endpoint defenses. It actively removes security hooks inside ntdll.dll.
Wow. ntdll.dll. That's
Yeah.
a core Windows component that handles system calls, right? Exactly. Antivirus and EDR tools typically inject their own monitoring code in there. They just sit there and watch for suspicious behavior. But TCL Banker forces the system to load a fresh, unmodified copy of NEDL directly from the disk.
So it's effectively just overwriting the security tools cameras.
Yeah, it wipes them out. And on top of that, it disables event tracing for Windows, which shuts off the operating system's built-in telemetry pipeline.
That is wild. And it also runs a series of really paranoid checks before it does anything else, doesn't it? Like, it looks for debuggers, scans, system disk info.
Oh yeah, it even verifies that the system's default language is set to Brazilian Portuguese.
Wait, really? Brazilian Portuguese?
Yeah. But it doesn't just run a simple if then statement to decide whether to hide. The implementation is brilliant. It uses the results of those system checks to generate a cryptographic environment hash.
Okay, so that resulting hash is then used as the key to decrypt the actual malware payload.
Precisely. So if a security researcher takes this malware and puts it into a secure sandbox environment to analyze it, and they have, say, a debugger running,
Then the hash generated by the malware will be mathematically incorrect.
you got it. Because the environment doesn't match the exact parameters of a real victim's machine, the decryption key fails. The payload never decrypts, and TCL Banker just quietly terminates itself. It throws 0 red flags.
Okay, but assuming it passes all the checks it's on a Brazilian system, the antivirus is blinded, it moves to data theft. And it uses something called UI automation to read the text inside your browser's address bar.
Yeah, UI automation. It's an accessibility framework built into Windows.
Right, originally designed to allow screen readers to parse text for visually impaired users.
Exactly. And TCL Banker hooks into this framework, so it doesn't need to break the browser's encryption or inject code into the browser process, which are super noisy actions that often trigger alerts.
It just quietly asks the Windows Accessibility API what text is currently displayed in the address bar.
Yep, it sits silently, waiting for you to navigate to one of those 59 targeted financial institutions. And the moment it sees a match, it opens a WebSocket connection to a remote command control server.
Ah, and this drops the malware into a dispatch loop. So a human operator on the other end basically gets a remote control for your computer.
Literally! They can run shell commands, launch keyloggers, and manipulate the clipboard to secretly swap out cryptocurrency addresses when you go to paste them.
But they also use these fake credential stealing overlays, right?
Yeah, using Windows Presentation Foundation or WPF, these are full-screen interfaces designed to look like legitimate Windows updates or vishing wait screens that tell you to hold while a customer service representative is connecting.
And the crazy part is, these overlays use specific Windows API calls to exclude themselves from screen capture tools.
It's entirely invisible to monitoring software. If a security tool takes a screenshot to look for suspicious pop-ups, the fake overlay just won't appear in the image.
Wow. But, I mean, the real devastating aspect of TCL Banker isn't even the theft, is it? It's the worm component. This is where that weaponization of trust becomes exponential.
Yeah, it uses an open source project called WPP Connect. Now, this is originally a legitimate tool used by developers to build WhatsApp bots, but TCL Banker utilizes it to physically hijack your currently authenticated WhatsApp web session.
Oh, no.
Yeah, it parses through your contacts and automates the process of sending the malicious ZIP file to your entire network. It also deploys a secondary bot that abuses the installed Microsoft Outlook application to do the exact same thing via email.
So this means the malware is spamming up to 3,000 of your own contacts with the infection. And it is coming directly from your legitimate WhatsApp account and your actual Microsoft Exchange server.
Right. If you work in IT, think about how traditional email gateways and reputation-based defenses operate. They look for suspicious sender domains or, newly registered IP addresses.
They are completely blind to this. I mean, an enterprise email filter has zero reason to block a message coming from a known trusted vendor or friend on legitimate Microsoft infrastructure.
Exactly. The attackers inherit the trust you have built with your network over years. When someone receives that ZIP file, their psychological defenses are totally down because the sender identity is fully verified.
It's brilliant in a really dark way.
Yeah.
So TCL Banker uses a disguise leveraging a friend's account or a Logitech signature to trick the system. But what if the attacker doesn't want to wear a disguise? What if they want to rewrite the fundamental rules of the system itself so the security tools are structurally incapable of seeing them? And that brings us to our second story, a report from Trend Micro detailing a new threat called Quasar Linux RAT, or QLNX.
Yeah, so we are shifting here from targeting individual user trust to targeting the foundational trust of the global software ecosystem. QLNX specifically hunts developers in DevOps environments.
Which is the huge target on its own.
Huge. The objective is to harvest high-value secrets. So we're talking .npmrc files for Node package managers, .pyperk for Python, AWS and Terraform credentials, Kubernetes configuration files, and GitHub CLI tokens.
Okay, wait, I have to challenge the severity of just stealing those files, though. We were talking about DevOps environments. These engineers used multi-factor authentication, physical hardware keys, zero trust networks. I mean, a stolen password shouldn't be enough to compromise the supply chain if the MFA challenge stops the login attempt.
Well, a stolen password wouldn't be enough. Which is exactly why QLNX targets configuration files like .npmrc and .piper.
Oh, because they hold tokens?
Right. These files don't just store passwords, they store long-lived authentication tokens and API keys. These tokens are generated after the MFA challenge has already been satisfied.
Oh, wow. So if a threat actor steals a valid NPM token, they just bypass the MFA entirely.
Exactly. They can authenticate directly to the package registry as that developer. If that developer maintains a popular software library used by thousands of other companies, the attacker can push a poisoned, malicious update to the registry.
Which means thousands of companies download a routine, trusted update for a benign piece of software and instantly pull malware into their own corporate networks.
It literally compromises the entire software supply chain.
But, DevOps engineers live in the command line. They monitor their Linux servers obsessively. How on earth is a remote access Trojan hiding from them?
Oh, QLNX employs a masterclass in extreme stealth mechanics. First of all, it executes entirely filelessly from memory.
So there's no executable binary resting on the hard drive for a scanner to find.
None. And when it runs in memory, it names its primary process worker, or softer cord.
Which are standard, essential background kernel threads in the Linux operating system.
Right. An engineer skimming a list of running processes wouldn't look twice at a worker thread utilizing a bit of CPU.
But a smart engineer troubleshooting a weird system load would run a command like netstat to see what network connections are open, right? They would immediately spot the server establishing a connection to a rogue command and control IP address.
Well, they would if the operating system was telling them the truth. QLNX deploys a two-tiered rootkit to create this reality distortion field around the malware. The first tier is a userland rootkit utilizing the Linux LD_preload mechanism.
Okay, so LD_preload, that's an environmental variable that forces the OS to load a specific library before it loads anything else, including the standard C library that almost all programs rely on.
Exactly. So by using that, the attacker's malicious library gets to intercept function calls made by standard diagnostic tools. When the else command asks the OS to list the files in a directory, the malicious library intercepts that request, edits out any files belonging to the malware, and passes the scrubbed list back to the user.
That's insane.
But it goes deeper than userland. It deploys a kernel-level eBPF component.
Right, eBPF Extended Berkeley Packet Filter. That's a subsystem that allows developers to run sandbox programs directly inside the operating system kernel.
Yeah, and it was designed for deep performance monitoring and network traffic analysis. But QLNX weaponizes eBPF to hook directly into the kernel's network and process management functions.
So it alters the data at the deepest possible level before it ever reaches the userland tools.
Yes. When the developer types netstat, the kernel simply omits the malware's connection to the C2 server. The monitoring tools are functioning perfectly, they're just being fed fabricated data by the compromised kernel.
Unbelievable. And it also features a pluggable authentication module, or PAM, inline hook backdoor, doesn't it?
It does. PAM is the central framework that handles authentication on Linux systems. By hooking inline into PAM, QLNX can quietly intercept and steal plaintext credentials right at the exact millisecond the developer types them in to authenticate a new session.
So the Trend Micro report basically highlights that the danger of QLNX isn't any single feature, but the cohesive workflow.
Right. It arrives, erases its initial dropper from the disk to destroy the Forenza trail, and sets up 7 redundant persistence methods. Yeah, it leverages mechanisms like System to create hidden service files that automatically restart the malware on boot, and crontab to schedule recurring executions just in case the primary process is somehow terminated. It can execute up to 58 distinct commands, all while remaining invisible.
Wow. Okay, so we've looked at malware, hijacking user communication channels.
Yeah.
And rewriting the kernel to hide from developers. But there's actually a much simpler way to exploit trust.
Always is.
Right. Instead of writing complex eBPF rootkits, an attacker can just build a completely fake facade and place it right where you naturally assume safety, the official App Store. Which brings us to our third story, a fascinating discovery by ESA regarding mobile fraud ecosystems.
Yeah, this one is wild. ESA uncovered a cluster of 28 fraudulent Android applications sitting directly on the official Google Play Store. And the scale of this campaign, they dubbed it Call Phantom, is staggering. Collectively, these apps achieved over 7.3 million downloads.
7.3 million, that's huge.
Yeah.
And they primarily targeted users in India and the broader APAC region. Mm-hmm. And the premise of the apps preyed on human curiosity and suspicion. They claimed to offer a highly sought-after, but technically impossible service, providing comprehensive call histories, SMS records, and WhatsApp chat logs for literally any phone number you entered.
And the monetization strategy was super aggressive. To unlock this supposed data, users were forced to pay subscription fees ranging from $6 to $80.
That's a lot of money for a mobile app.
It is. And they collected this money through legitimate channels, Google Play's official billing system, direct credit card entry, or massive regional UPI platforms like Google Pay, PhonePe, and Paytm.
Okay, so a user pays $80 and they receive absolutely nothing real in return.
Nothing.
The apps just display completely fake, randomly generated names, phone numbers, and chat durations that are literally hard-coded directly into the application source code.
Right.
But here is the massive question. How does an app with over 7 million downloads bypass Google's automated security scanners? And we just talked about malware needing kernel-level rootkits to hide. This app has zero actual functionality.
Well, that's exactly why it bypassed them. The automated security scanners deployed by major app stores are designed to look for malicious behavior.
Okay.
They look for buffer overflows, unauthorized API calls trying to exfiltrate contact lists, or hidden payloads attempting to root the device. The Call Phantom apps don't contain any malicious code. They don't request sensitive permissions. Structurally, they're incredibly simple, completely benign applications.
Oh. So the scanners are looking for technical exploits, but they aren't equipped to detect a lie.
Exactly. The malware in this scenario is simply the deceptive UI copy and the financial scam relying on human gullibility.
And the developers heavily manipulated visual trust signals, didn't they?
Yeah.
One publisher literally used the name indiangov.in to make their fake app look like an official state utility.
Yeah, and they also implemented psychological traps. Like if a suspicious user tried to exit the app or hit the back button without paying the subscription, the app would generate a deceptive system-level toast notification.
Oh, those little pop-ups at the bottom of the screen.
Yeah. It would pop up stating, the call history file has been successfully sent to your email.
Oh, that is so manipulative. That plays right into the sunk cost fallacy and the fear of missing out. The user sees that notification and assumes the data is real and already waiting for them, but it's locked behind a paywall.
Yep. So they click the notification, which loops them right back to the subscription payment screen.
Wow. And this reliance on social engineering and institutional trust, it's part of a much broader, highly concerning mobile fraud landscape. Like the corresponding report from Group IB details a threat cluster operating in Indonesia that they track as Gold Factory.
Right.
And Gold Factory managed to steal an estimated $2 million by impersonating the Indonesian tax platform, Cortax.
But the difference here is Gold Factory doesn't just rely on empty, fake apps that steal subscription fees. They are deploying serious Android malware, specifically the Gigabud RAT and a Trojan known as Tauten.
And they use a really blended approach to get that malware onto the device, don't they?
They do. They start by setting up convincing phishing websites that mirror the official tax authority. Then they integrate social engineering via WhatsApp, exploiting that trusted communication channel to message victims posing as tax agents.
Wow.
And then they follow up with voice phishing, calling the victim directly to guide them through the process of sideloading a malicious APK file onto their phone.
So, sideloading bypasses the official App Store entirely. But because you've been primed by the official-looking tax website and you have a helpful, authoritative-sounding agent on the phone guiding you step by step, you willingly ignore the giant Android security warnings telling you not to install unknown apps.
Exactly. Once you grant those initial permissions, Gigabud and Teddy take over. They harvest sensitive data and, crucially, they intercept incoming SMS messages.
Which allows the attackers to capture the multi-factor authentication codes sent by your bank.
Yes. Ultimately achieving full device compromise and executing unauthorized catastrophic bank transfers. Gold Factory has successfully abused the branding of over 16 trusted institutions in Indonesia alone using this exact pipeline.
Man, so taking a step back and synthesizing the practical impact of these three reports, it seems like the nature of cybersecurity defense requires a fundamental shift in perspective. We are no longer just fighting bad code. We are fighting the sophisticated manipulation of trust at every layer of the digital ecosystem.
That's the core of it. TCL Banker demonstrates the exploitation of inherited trust. right? Leveraging the inherent faith you place in your own WhatsApp contacts to bypass enterprise filters.
Right.
QLNX illustrates the hijacking of foundational trust, infiltrating the software supply chain by targeting the credentials of the developers who build the tools we rely on. And Call, Phantom, and Gold Factory show the exploitation of institutional trust, using the official veneer of app stores and government brands to facilitate massive financial fraud.
So when the signals of trust themselves are compromised, our defense mechanisms really have to adapt. It comes down to contextual verification. Like, if you work in development or DevOps, relying on tools like Netstat or Police is no longer sufficient if the kernel itself might be compromised by eBPF.
Absolutely. Defense requires strict credential hygiene, focusing on short-lived tokens and behavioral monitoring for anomalous API calls, rather than just perimeter defense.
And for you as an individual user, the concept of verification has to move off platform. We have to verify intent, not just identity. If an official-looking tax application wants you to install an update, you do not click the link provided.
Never.
You navigate to the primary government URL independently on a separate device to verify the requirement.
Right. And if you're paying for an app subscription that promises something technically dubious, audit your Google Play or Apple subscriptions today and cancel it.
Good advice. And most importantly, treat out-of-character messages with a healthy dose of skepticism, especially if they come from a known contact. If your best friend suddenly sends you a ZIP file on WhatsApp with no context, verify it through a completely different medium. Just call them on the phone.
Yeah, the old adage of trust but verify really needs an update. We're entering an era where we must assume, compromise, and verify everything.
Definitely. And as we wrap up, there's a thought-provoking implication to all of this that we really need to consider. Everything we discussed today involves some level of manual effort, pre-programmed automation, or human-operated social engineering by the attackers. But artificial intelligence is scaling exponentially.
Oh, yeah. AI models are already capable of writing complex code, analyzing vulnerabilities, and generating highly convincing text.
Right. So what happens when these trust hijacking techniques are entirely automated by AI? Imagine a piece of malware that doesn't just spam your 3,000 WhatsApp contacts with a generic link, but uses an onboard large language model to perfectly simulate your unique communication style. It references inside jokes, it mimics your exact typing cadence, and holds distinct contextual conversations with every single person on your contact list simultaneously.
Or consider an AI that can instantly generate thousands of harmless-looking, perfectly localized fake apps, dynamically adjusting the social engineering tactics in real time based on the user's reactions.
Exactly. When the digital signals of humanity, our writing styles, our voices, our trusted platforms can be flawlessly and instantaneously synthesized at a massive scale, how will we define verification in the future? Something to think about.